You all written it?
I'm writing it.
Yeah? Have our books open. Press pause to wait for you. I'll rub that out and we'll write it down properly. But well done, Milo. That was correct. I think you figured out your slight mistake. But the method was correct. So, first step. What's up?
He did 5 divided by 10?
I said, should we go through the steps now? That's what I'm intending to do.
Okay.
Yeah?
But continue.
No, I will go through step by step now. Alright? So the first thing was Milo decided, and he was correct. We're going to simplify the numerator first. Okay? So Milo said because of bed maths, yeah? So you do your multiplication, get that sorted. It's kind of like having brackets. You do everything on top of the line first. So simplify the numerator first. So a to the power of -5 multiplied by a to the power of 3. We do a to the power of -5 add 3, yeah? That's what we do, right? So that gives me a to the power of -2. Alright? Good to start with? Alright. So, what we then have, if I use this and put it back into the question, it's now a to the power of -2 divided by a to the power of 4. Okay? Everyone okay with that so far? Yeah? Any questions? No? Now what we do. So step 2. Now we're going to simplify the division. Okay? So how do we simplify the division? Well, this is a to the power of -2 divided by a to the power of 4. We can do that as a to the power of -2 subtract 4. Yeah, we subtract the powers, exponents. So that becomes a to the power of -6. Okay, which, by the way, is a perfectly acceptable final answer. Okay, I could leave it as a to the power of -6, no problem. If it just says simplify it, you could leave it like that. But, okay, so let's say just if the question asks for positive exponents only, alright, then this is not quite right. So if it's positive exponents only, a to the power of -6 must be written as a to the power of 6. 1 divided by a to the power of 6. So then we've got positive exponents only. Alright? Alright. Not super difficult? No?
I thought it was going to be a lot worse.
Well, they do get a bit harder. I'll give you one other example. Right, so V. Question B. So what's that? 1V.
Multiplication?
Yeah, it's still multiplication. So, it's a good question. It's a very good point to start us off with, because my first step was going to be, let's rewrite it, but using symbols that are not normally necessary in algebra, but it might help us understand. Now, eventually, you'll say, right, we don't need to bother with that. So the step that I'm going to do first is actually just to rewrite it as 12 multiplied by d to the power of 2, d squared, multiplied by e, multiplied by f to the power of 3. Okay? All of that is divided by 36 multiplied by d to the power of 2, multiplied by f to the power of 2. Okay, so I've just split it up. Are you all okay with that? Not done anything with it yet? There's nothing I can simplify on the top because all the letters are different. The bases are different. Right? And there's nothing I can simplify on the bottom because they're all different. However, these are all divisions, right? Now, do you remember, if I take you back to this slide, how I said we can split all these up? All right? So 9 divided by 9 is actually 1, yeah? And 9 divided by 9 is 1. All right? So we broke them up. Now I'm going to use that principle here. And I'm going to break it up into bits that are not equal, wrong word, but using the same terms. So, numbers alone, D's, and X. All right? So this is how I'm now going to write it. So from here I'm going to write it as 12 divided by 36 multiplied by d squared divided by d squared multiplied by e, all right, multiplied by f cubed over or divided by f squared. All right? Again, eventually you might choose not to do any of what I've just done because you'll get to the stage of going, yeah, well, I understand what I'm supposed to do, so I don't need to do any of that. I'm going to get there quicker. Right? Do you understand that? So what I'm doing is I'm trying to explain to you the kind of the reasons why I'm allowed to do certain things. All right? So we can split up divisions into their separate bits that work together. Now, the reason why that's useful, okay, is because I can do each bit separately now. So does anyone know how to simplify 12 divided by 36? So it's a fraction, isn't it? So we can simplify it. Can't be 12 over 3.
3 over 12.
Nope. Close.
Oh, 3 over 36.
Nope. You're guessing now.
No,
Sam?
it's 12 times 3 is 3.
It's not 3. Close. It's
3 over 1.
no.
1 over 3.
It's 1 over 3, isn't it? Remember, if I divide by 12, top and bottom, I get left with
2.
1. Sorry, 12. 12 divided by 12 is 1. 36 divided by 12 is 3. Yeah? What's the next one then? Well, d squared divided by d squared is?
D squared. D.
It's not, is it? Let's look at it. It would be d to the power of 2 minus 2 because it's division.
So it's 0.
No.
Just-
So it's d to the power of
1.
0.
But
2
you don't
minus
put the
2
zero.
is 0. d to the power of 0 is 1, isn't it? Remember, one of the first things you learn, anything to the power of 0 is, and you also hopefully would know that if you take any number and divide it by itself, the answer is 1. These are the same thing. So we've got it, instead of d squared divided by d squared, we've now got a 1. Okay? E. Nothing. Doesn't. Just stays. Nothing to simplify that.
Just
Multiplied by, right, how do we simplify this? We've got f to the power of 3 minus 2
f to the power of 1.
f to the power of 1.
And you were better as F.
Or just f, yeah. So this is f. Okay. Everyone good so far? Yeah? slightly more to do, but nothing harder, right? Just more to do. All right. Now, how do we simplify that? Well, my tip would be anything without a division, we put a 1 underneath. Because then what we can see is now the top becomes 1 multiplied by 1 multiplied by E multiplied by F. Yeah? And underneath is 3 multiplied by 1 multiplied by 1 multiplied by 1. So how does that simplify? 1 multiplied by 1 is multiplied by E multiplied by F, EF. Just that, yeah? Divide by 3. Okay, I'm going to show you the shortcut method now. Alright? But I want you to be aware that the shortcut method has pitfalls in it, and I want you to know how we got the correct answer, and hopefully by knowing the correct answer you'll understand why the pitfalls of doing the short method are what they are. Alright?
What do you mean by pitfalls?
Pitfalls as in like stumbling blocks, or if you have a pitfall, you can be walking along, sailing along nicely, and then you fall into a pit, and that's a problem, right? You get stuck. So if there's a pitfall, it means there's a problem. Alright? So there could be a problem with the way we do things. So I'm going to go back to this question. Alright? Same question, I'm going to do it the shortcut method. So let me just... Right. It's useful, this board. Alright, so we're going to do this question again. But this time I am going to do the shortcut method. And the shortcut method involves crossing stuff out. Alright? So, this is how I would do it rather than writing everything out. I would say, alright, again, we have to do what I did before, but I'd look at the numbers and go, right, is there a common factor in 12 and 36? So I would just do it, so okay, I'm going to divide by 12 and divide by 12, same thing, but this is, instead of doing that, you might want to not write at this stage and just do it afterwards yourself. I'll go through it. If you just watch what I'm doing, all of you. So what they would do, because also then it's like you can see the problems happening. So if you haven't put pencils down for now, even colours and things like that. So this is what they do. They say, right, how many 12s go into 36? So they cross the 12 out, cross the 36 out, and put a 3. Yeah? Then they say, right, there's a d to the power of 2 and a d to the power of 2. So what they do is the division cancels it out. So anything below, they cross it out. They just cross it out. Well, you know it's equal to 1, right? But they're just going to cross it out. And then they say, right, what do you do? Well, if I've got 3 f's on top and 2 underneath, these 2 will cancel down 2 of them and leave me with a 1. All right? So then I look at what I'm left with. I'm left with an E on top, an F to the power of 1, so I don't need to write the 1. And underneath, I've crossed everything out apart from the 3.
So much simpler.
It's simpler. Now, the problem with it is this one's fine. But sometimes what happens is, especially if you cross everything out on the top, alright, people then think, well, what's on the top? If I've crossed everything out, what's left? And they think nothing. So they put a 0. Alright? But you know it's not nothing. When you cross things out, you don't get nothing, you get 1. Good. And that's the important bit. That's where all the mistakes with this method, the shortcut, comes from. Thinking that things get crossed out and they disappear. They don't. It's a division and they become 1. Right? It's not nothing, it's 1. But multiplying by 1 does nothing. Yeah, mathematically. Does that make sense? All right. How do you feel? Would you like to go through another one? Or are you ready to get on with the rest of those yourself?
Get on with another one.
Well, put your hand up if you'd like to go through one more. Okay, let's go through one more. Yes. Are you desperate, or can we? Can you tell me another question then, guys? That one that's like that.
3p.
3.
Oh, you.
3p
Negative 4.
to the power of negative 4.
Q.
Q
To the power of negative 1.
to the power of negative 1.
Divided by 6p to the power of 2. And then q to the power of negative 4.
Okay. So this is actually a quite good one because the crossing out doesn't really work. Because we've got negatives on top. Alright, now I'm going to show you 2 methods. You're okay with 2 methods?
Yeah.
Or do you just not want me to mess up what we've already done? Okay,
2 methods.
let's try it. What do you know about negative exponents? What do they mean?
Become positive.
They don't just become positive, they...
To be negative.
No, how do you rewrite a negative exponent? Kind of did it wrong. The negative becomes 1 over here. Now, do you remember I said if we have 2/3 to the power of negative 1, what happens? It becomes 2 to the power of negative 1 and 3 to the power of negative 1, and then we kind of end up with 3 to the power of 1 and 2 to the power of 1. If that was a 2, it'd be the same thing. 2, 2. Now, do you remember me saying that if a negative exponent, you can basically put it at the other side of the line? That was the shortcut. Does that make sense? Do you remember me talking about that? If not, I don't want to go down that route. Are you okay with what I've just said?
Yeah.
Or should we not? So what I'm going to do, I'm going to use this to help me start this one off. Alright? Basically, what I'm going to try and do is get rid of all the negative exponents first. Alright? Because negative numbers cause problems for almost everything. So what I can do is get rid of the negative. So we're going to change, we're going to deal with the negative exponents. And the way I'm going to do that is, are you happy enough that you notice that basically they flip upside down, yeah?
Yeah.
So every negative exponent, basically, I'm going to put on the other side of the line. So 3 and 6 stay where they are. All right? The p squared stays where it is. Right? But the p to the power of negative 4 goes down there. Got that, Luke? Need to be fully focused, like I said. All right, are you happy with that? So I've dealt with that one. What about the q to the power of negative 1? That goes
Q, negative 1.
down here.
Yeah.
Yeah? That's dealt with that one. What about the q to the negative 4 under here? That goes up. So I can put the q to the power of 4 up there. So I have dealt with these 3 negatives and they become positives but the other side of the line. Make sense? Alright. The reason why that's then useful is because I'm now going to do this. What does 3 and 6 simplify to? 1 and 2. Yeah? Happy with that? Q to the power of 4 simplifies with Q. So one of those, the 1, simplifies and becomes a 3. Good. Yeah? Is there anything else that simplifies top and bottom? No. So now what I've got on top, I've got 1, which I'm not going to write. I'm going to write q to the power of 3. What's underneath? 2 to the power, 2, just 2. But then I've still got this to deal with, and they're both p's. So what does that become, Alistair? Good, well done. Yeah? And that's me done. Alright? How do you feel about that? Would you like me to tell you the other way that I might do? Right, you might prefer the other way. Right, so let's have a look at it. Let's have a look at the potential other way. Okay. So, again, I can put this back if you want in a bit. Right, so let's do it again. But I'll tell you what I'm going to do this time. I'm going to do the whole rewriting thing. So I'm going to rewrite this as, that's not the same question, is it? Might need to read it out for me again. What was it? Okay, right. So the other method is to use the splitting it up thing. But again, I'm going to take a little bit of a quicker approach. So I'm going to say it's 3 divided by 6. Yeah? Then I'm going to say it's multiplied by p to the power of, because it's division, we have -4, subtract 2, multiplied by q to the power of -1, subtract -4. Alright? So what does that become? Well, 3 divided by 6 is a half. -4, -2 is p to the power of -6. Q, -1 minus -4 is p to the power of what?
-5.
Not quite. It's actually +3, isn't it? -1 add 4 when you've got subtract a negative. It's like adding 4. Yeah? Alright, so now what do we do? Well, we know that a half multiplied p to the -6 is 1 divided by p to the power of 6 multiplied by q to the power of 3 over 1. Yeah? So what does that become? Q to the power of 3 over 2p to the power of 6. Is that the same answer we had before?
Yeah.
It is. Alright? So you choose whichever works for you. Alright? As long as you're getting the right answer, you choose.
How did you get the
Remember, where is it? Remember with that one there,
Yeah.
I put the ones in to show that they could simplify like that. So I basically just used that process again, right? So I've used that and said, right, so I can multiply all these fractions together, I just put a 1 underneath to make it easier. All good?